Welcome to Real Civil YouTube channel. In this video, I am going to discuss with you some of the important updates from IS 1893 2025, and I am going to compare with IS 1893 2016. Okay, so we'll start with the map of India showing seismic zones. Okay, so here you can see in 2016 there were four zones, or India was divided into four zones. Now if you see, this is IS 1893 2025. So the number of zones now changed to 5. Okay, and some of the key features of revised seismic zone map are like seismic zone 6, which is like a high risk, which is here you can see the highest risk. You can see this belt here, so this region. So entire Himalayan arc is now classified as a seismic zone 6, and we know that here Indo-Eurasian plate boundary is there, and because of that uh, the risk is high. Now if you watch or see this carefully, 61% 61% of the India now falls under the moderate to high seismic hazard zones. Then the philosophy behind the seismic zone definition is probabilistic hazard model. Next important thing, that design acceleration coefficient AH. We know that VB, base shear VB is equal to AH into W, where W is the seismic weight of the structure and AH is the design acceleration coefficient, are now explicitly tied to the return periods based on structural importance, making a significant shift towards a more performance based seismic design approach. So if you see, yeah, this is from IS 1893 2025. Now there are zones. Okay, as I told you, 5 zones are there. Previously in 2016, there were 4 zones, 2, 3, 4, 5, and zone values was there. But now the zone values are also linked with the return period of earthquake, and these return periods are depending upon the category of the structure. Okay, so again this is from 2025, that category of the structures are given, which types of structures are there are explicitly given. Okay, and against that the return periods are mentioned. So in combination of these category of structure, return period, the zone values are defined. Next is this is from 2016 code, the formula Z by 2 SA by G into I upon R. So you can see there are some changes in the formula for AH. The formula for the design horizontal acceleration is redefined for each seismic zone and return period. So the formula for AH is little modified. Then very important, the design spectra. If you remember the time period or the response spectra for the equivalent static method as well as for the response spectrum method, uh, as this is from 2016, it was up to 6 seconds. It was up to 6 seconds, but in this revised 2025 IS code, it is now been extended to 10 seconds for both response spectrum method, and here you can see equivalent static method. It is up to 10 seconds. So the benefit of this revised response spectrum now extends up to period of 10 seconds, enabling accurate representation of long period ground motion effects that governs the response of tall, slender and flexible structures. Then very important, the response history analysis or the time history analysis. Now it has been very much strengthened because the Bureau of Indian Standard now supplies standardized ground motion or time histories, those suits for the seismic zone 2 to 6. Okay, and it covers both near fault and far fault scenarios, and these records are required to be spectrum compatible through proper scaling. So because of this, it is more realistic and reliable dynamic seismic analysis. So this is how the response history is strengthened. And the last point that I would like to discuss in this presentation is of soil structure interaction. The updated code, revised code, gives clear guidance to account for soil flexibility in analysis. So, no more fixed base assumption for soft and deep sites, model for foundation spring or subgrade stiffness as per the code. So clear guidance is now given for the soil structure interaction. So these are the some of the points I have discussed in this presentation, in small presentation related to IS 1893 2025. Thank you. Thank you so much. Please like, share, subscribe the channel. Thank you so much.